Hello, I'm Professor Bustillo-Booth. Welcome to this video session where I will go over how to diagram a system using the systems basics as described by Daniela H. Meadows in her book, Thinking in Systems. If you don't already have a pen and paper in hand, please be sure to go get that now so that you can follow along. Let's go ahead and get started. In this video session, I will go over the difference between linear versus systems thinking, as well as discuss the value of systems diagrams. I will then walk you through the systems basics and the kinds of graphics you'll be using in order to create those diagrams, and discuss the kinds of feedback loops, particularly reinforcing and balancing, that are so common in systems. And then I will provide you some feedback loop examples. Linear thinking really asks why questions. So for example, if you hear somebody asking questions that begin with why, that's pretty much a sure sign that that's linear thinking. So for example, you might hear them say, why do birth rates affect population size? Or why did I get gas for my car? When you hear that, it's a sign that's linear thinking. Linear thinking also follows this idea of if, therefore, then reasoning. So you might hear something like, if birth rates go up, then there are more people. If the gas in my car is low, then I get more gas. So again, it follows that if, then type of reasoning. Systems thinking, on the other hand, asks what and how questions. For example, you might ask, how does a population grow? Or what factors does a person consider when filling up their gas tank? Now, systems thinking accounts for how parts interconnect and affect the behavior of a whole. It is a holistic approach. Linear thinking, on the other hand, takes a step-by-step approach. It uses prior information to inform next steps. Now, systems thinking uses information feedback loops to understand how variables affect other proximal and distal variables. The value of systems diagrams are many, one of which is that it helps you identify the parts in the first place, and then it helps you illustrate how those parts connect into a whole. And it also helps you demonstrate by depicting how they are connected, how they come together as structures, and then how then those structures create behavioral patterns. And that's really insightful when you start to see how the parts themselves create how the system behaves. And then it'll let you understand how those behaviors then led to results. Ultimately, the diagrams is a good analytical and evaluation tool to explain what may be happening in the system, and ultimately give you some ideas about possible responses for desired outcomes. It gives you a more accurate and offers you more rich information than if you were just to consider linear thinking. Now, it's important to note that linear thinking and systems thinking, one is not better or worse than the other. They're just different ways of thinking. And in fact, in systems thinking, there is linear thinking, right? It's embedded within it. But it does allow, systems thinking allows for a greater aperture, so you can see more of what may be happening than what may be immediately seen. So the systems basics that we'll use are the kinds of graphics that Daniela Meadows used in her book, Thinking in Systems. And if you have your book now, it'll be good to have that with you so that you can flip through and follow along. Maybe that will help. In this case, you'll see that there's a cloud, and we loosely call that origin, meaning that it's the near source for the stock that is in question. And a stock, it could be anything, and it is what you're trying to understand what's happening to it. And the stock generally rises and falls in levels or changes in states or condition. And between them is this idea that from the origin, wherever it came from, it comes from somewhere and then goes through sort of a delivery system, right, and affects the level of the stock. From a linear perspective, if you were just to follow from origin to the delivery system to the stock, you would have, again, followed that linear aspect of how that stock came to be. What makes systems thinking distinct is that you would then explore what explains that flow, that the amount that got that affected the stock. So that would be called the information feedback loop. So this arrow really represents the kind of information that are being considered or that are just affecting, in this case, the flow rate of the stock. And in Meadows, she talks about a bathtub and how the water source coming from wherever it came from is delivered through the pipes, right, and then goes into the stock, in the bathtub. And the kinds of information that's affecting the flow rate include things like how much water the user wanted, the hot and cold state of the water as it left the pipeline into the tub affected how much of the spigot how much of the water was let in. And then ultimately there was a decision, oh, that's enough water. And so that's part of the information, right, that the user then acted upon. And so this information at the bottom here is really sort of the additional insight that you would get when you put together a systems diagram. Now, there are two major feedback loop behaviors. They're generally called reinforcing and balancing. Now, we use the term reinforcing in a regular vernacular differently, so we want to spend a little bit of time taking this apart in the context of systems theory. Reinforcing loops, the meaning of that is of amplification. So reinforcing loops amplify the inputs or outputs, okay, the effect. So they're self-multiplying and they have this exponential effect. So generally it would either go up or down. And it's not meant to be a value statement of being up being better or down being better or worse. It really is just directional. So think of it that way. It's a direction, and that whatever the inputs are coming in is reinforcing the direction that it was already headed. Of course, there might be a little bit of variability as it goes up, but generally speaking, that direction is maintained, whether it's going up or going down. The balancing feedback loop, on the other hand, aims to maintain a desired goal. And that goal can be implicit, it's not really known, or explicit, that it's stated. And it achieves this, it being the system, achieves this by closing the gap or the discrepancy between actually the state and the desired state, right? And so the system, if the system wants to achieve a certain goal and it starts to get out of balance, then it starts to push back on the other side to try to maintain that. And it just sort of oscillates and teeter-totters in this dynamic between the inputs and outputs to try to maintain a space, or a state of equilibrium. Now, let's talk a little bit more about this reinforcing loop. And again, we're using Meadows diagramming tools. And so the stock originates from someplace, and it's denoted as a cloud because we're not really discussing the effect of this. It is really another stock, right? But we put it as a cloud because that's not really our major area of interest. What we're just trying to say is we recognize it comes from someplace and that it's being delivered in some way to affect the stock level, right? And that in the reinforcing loop, it has a net plus or minus, plus increase or net decrease effect. Right, so there could actually be pluses and minuses going on in here, but ultimately either the pluses overpowered or the minuses, or the inputs overpowered or the outputs overpowered, having a net effect of either plus or minus. And so reinforces the direction of the inputs and then affects the rate. Okay, and so when we talk about rate, that could mean the policy or the rule or what have you is represented by this valve over here. So let's use as an example, let's use births as an example for what a reinforcing loop might look like. So the stock here is population, right? And then the origin, the population started out somewhere, and then there is some kind of delivery mechanism for the population to increase or decrease. And by looking at the system dynamic, and this is one system dynamic of population, there are others, you could see, for example, a population inflow is affected by the number of people having babies. And I've denoted this kind of, a thinner line, so you can see that it sort of amplifies, it gets thicker as we go along here. In this case, the net effect is that as people have more babies, those babies grow up and they also have more babies, they affect the birth rate, increase the birth rate, right? So you have an increasing population in this case. On the other side of that, the idea of a balancing loop. We would draw the stock, right? And there would be some kind of outflow delivery mechanism where the stock would go to another part of the system, which we won't discuss, but we'll denote that it does go somewhere. And that there is a sort of forces at play that more or less equal out, because the goal, whether it be known or not known, is really to achieve some kind of desired goal. Okay, we call that stability or equilibrium, and those terms are value neutral. It's just meant that, as one pushes the one direction, another set of variables pushes in the other direction to try to achieve some kind of stability. Okay. But generally speaking, the system recognizes that there's discrepancy, and that's why there is this dynamic between the inputs and the outputs trying to come up with, some kind of balancing state. Okay. Now let's use deaths as an example of what a balancing loop might look like. We'll use population again as our example, and there is also some kind of, quote unquote, delivery mechanism where deaths occur, and where people move on to, in this case, we'll call the afterlife. And in here, you always start from the stock, and the arrow goes down here, and again, this signifies information. And the information, and we're simplifying, there's certainly many variables that affect deaths, but in this case, we'll just talk about the inflow of the number of people who are aging is increasing, right? Now, the system has an implicit goal of sustainability, meaning that the body, when it starts to, get old and use up, the system starts to die off as a way of maintaining, kind of the balance between life and death, right? As the number of people who age increase, there is a natural countermeasure within the system to respond with the increase of the number of people who die as a result of aging. And so given within the natural world that people don't live an infinite life, there is a limited life, and the way the system balances that out is as people age, then they start to die off. And again, I want to note that these terms are value neutral when we talk about pluses or minuses and sustainability and so on, that they're neither good or bad. We're really just describing how the system is behaving and what its current state might be. A system dynamic, it's completely possible that both the reinforcing and the balancing loops are present. In fact, that's quite common. And in here, you'll see how that might look, right? So again, a stock comes from somewhere, and this, we note it as a cloud because we're not going to talk about it so much. There's a delivery mechanism, and its flow into the stock is affected by some rate, but that rate is really informed by this reinforcing loop, right? And as that stock moves on to sort of its, adjacent area, that it might have itself a balancing effect. Inflows or outflows, but the net of that is a sense of implicit goal where they try to maintain, some kind of stability. All right. Then we're going to look at population growth here as an example of how the reinforcing and balancing loops can exist near each other. And in here you can see a stock, right? People come from somewhere, but we're going to just notice as a cloud in our diagram. There's a delivery mechanism for the birth rates, the births, and it's affecting the level of the population. The population eventually dies off and they move on to greener pastures. And as you may recall, that one side of that is a reinforcing mechanism that birth begets more birth, so the population increases, and that but on the other side of life is that there is a balancing loop that as people age, right, more of them die and then move on to the afterlife. And you can see here that which of the reinforcing or the feedback loop or balancing group is more dominant really determines what's happening in the population growth in general. So in this case, if you were to say, for example, look at this in some parts of the world, say India, where the population growth is increasing, you might say that there are more people who are born, having births and increasing, but the death rate is lower. And so generally speaking, living in India, then there are people who are dying in India. So population is growing. In other parts of the world, like Japan, for example, you might find that the reinforcing is not that births beget births, but that as the women population goes into work, they're delaying, having babies and maybe choosing to have less babies. And so the birth rate is actually decreasing. And so that's a reinforcing effect of a decrease in births in Japan. And then on the other side of that is that their aging population is growing, in part because it's just they don't have as many young people, but they also have longer lifespans, and so they're living longer, and so the death rate is less. It's an interesting dynamic that they have in their population vis-a-vis India. Let me give you an example, the gas tank example, and this is the one-stock balancing loop to kind of further discuss what a balancing loop might look like, and also the value of labeling your diagrams so that you can be clear to the user what it is that you want to try to communicate. So in this case, we're still using the cloud to denote that the gas came from somewhere, and we are not discussing this right now. We're just acknowledging that it exists. There is a delivery mechanism, right, that is affecting the level of gas in the tank, and that that gas ultimately goes someplace. And here you'll see, and I went ahead and color coded, and if you're able to do that, great. If not, just make sure your labels are clear. That in this case I denoted the outflow as yellow in this case, and I labeled what I meant by that outflow. So I'm not asking people to try to figure this out. I'm going to be very explicit what I mean about an outflow, and in this case I say its outflow is a decrease gas use, right, due to trips, what causes there were, performance, road conditions, and so on. And I'm also noting that there is a goal to have a level of gas to meet traveling needs, and that at some point there was a discrepancy, and why there was a counterforce, a counteraction, right? So this was an action of just going on the road, doing my own thing, and then eventually the gas level was so low that it created a discrepancy between my need and what I actually wanted. And so then there's an inflow of that gas going in here, and those are informed by gas purchased given the gasoline price. Maybe I had a great deal, so I put more than usual, or maybe not, so I put less than usual. It could have been affected by my amount of time that had in order to fill the tank. Maybe I only had 10 minutes, maybe I had an hour before I went to work, so I had more time to fill the gas tank, or just a need in general. So you can see that in this information feedback loop, there's a lot of variables to consider on how much gas then to put in, and how fast, right, that put that gas into the tank. And so in this case, it's really super important to make sure that your labels are clear, and if you are able to color code, it might help with the visualization for your user to understand what it is you're trying to communicate. The diagram can only say so much. So when you write your narrative, you want to be clear about its connections, right? So it reads more like a story in this case, and that's what you want to do for the user, is to create that clear storyline. Finally, I want to discuss a little bit about another set of balancing and reinforcing feedback loops and how they can appear in a system together. And also how important it is to label the parts and what's happening in the system so that when the user takes a look at your diagram, they generally get a sense of what's happening. And then when they read your narrative, the two together work as one. So as you can see here, we're using, and this is the aggregate, meaning not just one car, but say cars within the United States. So gas in cars in the United States in this case, they come from gas sources and there's a delivery mechanism. And how much goes into the cars, right, is affected by the usage of the car and the amount the people in general want, and then they take action to fill on their gas. And in this labeling, you can see that a written net of inflows and outflows with goal to achieve desired gas levels. And you could have certainly have said more, right? Like in the previous slide, there were reasons that were listed here and for the outflows, and then reasons that were listed here that were reasons for the inflows. You can certainly do that. And here, and that's the balancing aspect, right, as discussed earlier. There is also, you could draw the reinforcing, certainly could have done it below here, but you can also do it above, as long as you're clear about what you're trying to do. And do the labeling, you could say amplifying effect of policies that prioritize fossil fuels. And you could see that as more cars are built to take on fossil fuels, it will have an amplifying effect on the emission rate, because there are very little of the policies that would counter the use of gas, which creates the gas emissions, right? And in this labeling that you can see, it's fairly simple. And if you were to do it in this way, where you're not writing the inflows and the outflows directly into the diagram, you'll want to make sure that that is in your narrative. So that's very clear, where you are providing that analysis in narrative form needs to be very clear, where you're putting in the parts, how the parts connect, and what the causes are, and ultimately how the stocks are affected using the system's behavior like balancing and reinforcing. This brings us to the end of the video session. I hope this was useful to you. Drawing systems diagrams can take practice, and the more you do it, the better you'll be. Just keep in mind to be consistent on how you label, and be clear about your variables, and make sure that your story holds together, particularly as it relates to the diagram that you provided, and you'll be just fine. Thank you again for joining me during this video session. And if you are one of my students and need further assistance, please do reach out. My contact information is in the syllabus, and I'm happy to help you. Thanks again.